Okay, hey guys, so before you start, you need to make sure that your foldable is like this in your journal. Can you see this? Yes. So cut it out, cut each flap apart, glue down just this little piece on the side right there. So if you haven't done that, stop this video, do that real quick before you start the lesson. Okay, so talking about force and motion, and you're just going to be filling in the vocabulary as I teach you each one, but I'll show you what to write as we go through the slides. So here we go. Okay, so your foldable should look like this. Let's start with this picture. So first, a force, we have a hand signal for this. A force is a push or a pull. That's it. That's all a force is. A push goes away from you and a pull goes towards you. So in this picture, we would have a pushing force as the girl's going away. Motion just means to change positions. So you're not actually in motion unless you move from like one point to the next. Okay. So this girl definitely has motion, and so does this man that's pushing her. So she's changing positions from way back here to up here, and he's changing positions as he actually moves forward and pushes her. So we've got a pushing force and we have motion from both people. Just means movement, to change positions. This one definitely have a large pushing force. So notice how this one, because this guy has more mass than I'm sure this guy, we have a lot more force on this one. So a lot of pushing force. So he's pushing into him. The push of this guy is kind of pulling him back. So see how he's getting pulled backwards as this guy pushes forward. Lots of motion from both people. They are definitely changing position. Okay. So on this one, we've got pulling forces on both sides. So we've got parents pulling on the left, kids pulling on the right. So they're both using force. But if you've ever played tug of war before, and if you're both pulling with the same amount of force, nothing happens. It's like if I try and pick up a house, I can pull and pull and pull and pull. If nothing happens, there's no motion. Remember, to have motion, you have to actually change position. Now, if the parents are stronger, then yeah, it'll have motion. The rope will obviously come this way, over here. The kids are stronger, which doesn't look like it is, then it would go this way. So let's say, for example, because you're going to be able to measure force this week using a tool called a spring scale. Let's say these parents are pulling with a force of 500 newtons. Newtons is the unit that we're going to use, like Isaac Newton, if you know who that is. He's the scientist that came up with the laws of motion. These parents say they're pulling with 500 newtons. Let's say these kids are pulling with 500 newtons. Well, if they're pulling with the same force, there's no motion. They're just going to be pulling and pulling and pulling and nothing's happening. But let's say the parents are pulling with 500 newtons and the kids are pulling with 100 newtons. Who's winning? Obviously the parents. Okay. So this is the tool that I told you, the spring scale. We're going to be using these this week. This is just a tool that measures force. So it can look like this right here, or these, and they have all different kinds. Like some only go up to 5 newtons, some go up to 20. So when you pull on them, it's a spring scale. So this spring just stretches out and this little disc moves up and down, and it tells you how much force you're pulling on it. Okay, so we will be using these this week. You label everything, like I said, in newtons, which is a capital N. So it's Isaac Newton is the scientist that it's named after. He's a physicist that came up with all the laws of motion, like I already said. So it is a capital N. A lowercase n stands for nano, like nanoseconds, which is like smaller than 1 second. So spring scale measures force in newtons. Okay, so you're going to stop here, open up the little force tab, and copy down these notes. A force is a push or a pull. We use a spring scale to measure force in newtons. So pause this and copy that down. Next is going to be motion, just means to move and to change position. So I actually have to change from one place to the next to have motion. Okay, so pause this, copy that down. Okay, next, what are the forces involved here, and is there motion? There's definitely motion because they started here, I'm assuming, or maybe up here, and they are changing position. What are the forces involved? Well, if you're jumping off of something, that's a push. So they have to push off the cliff, and then they're getting pulled down. Well, you should know this. What's pulling them down? Gravity. Gravity is what's pulling them down. So gravity, which you're going to copy this down, pulls all objects down to the center of the earth. So our earth has enough gravity to hold us all down to the center of it. Now, we don't go to the center of the earth because what's the earth made out of? Solids. It's rock. So it's pulling us, but the ground is helping us stay on the ground because we can't pass through a solid, right? So it pulls all objects down to the center of the earth. So like if we go to the moon, there's still gravity, there's just less. So we still get pulled down to the moon, it's just less, so it takes you a while to get pulled down. Whereas like if I drop this journal, that happens really fast. On the moon, it would be more like this. It would just take longer because the moon has less mass. If I took this to the sun, like squash before you could even blink or tell where it is, it'd look like it disappeared because the sun has more mass. So its gravitational pull is way bigger than the Earth and the moon because it's bigger. That's it. The moon has less gravitational pull because it's smaller. Everything has gravity. It just depends on the size, if it has a lot of gravity or just a little bit. The only thing that doesn't have gravity, if it's not matter, it doesn't have gravity. So in the middle of outer space, you would just be floating around because there's no air, there's no nothing. So it has to have matter to have gravity. So like these sunglasses have gravity, but they're so teeny tiny that the gravity of these doesn't make me like stick to my sunglasses, right? That doesn't make sense. The mass of the earth is way bigger than everything on it. So everything falls down to the center of the earth. So the more mass something has, the more gravity. So copy that down. Okay, so if you look at this picture here, what are they using this spring scale for? Okay, this is not how we're going to use a spring scale because think of what is pulling these potatoes down. This is weighing the potatoes. Okay, so gravity's pulling it. That's why they're using a spring scale because gravity is a force. It's a pulling force because it pulls you down. If I fell out of my chair right now, I would be pulled down. Okay, gravity's pulling these potatoes down. So they're actually finding the weight. You may have seen at the grocery store in the fruit and vegetables section, they have those trays where you can put your vegetables and fruit inside of and it weighs it for you. That's a spring scale. So if we hold a spring scale like this, we're measuring how much gravity pulls on it, and that's weight. So we won't be using the spring scales quite like this. I'll show you in a second how we're going to use them. Okay, what kind of force is this? We've already learned this. This is magnetism. Magnetism is a force because think of when the nails go to it, the nails are getting pulled to the magnet. So magnetism is actually a force. But we've already learned about that. So what has magnetism? Zinc, steel, iron, nickel, cobalt. So magnetism is a force. Okay, last one is friction. So friction slows things down. Okay, that's our hand signal for friction. Friction has two touching surfaces, and friction slows things down. So if you look up here, I have friction as the opposite of motion. Well, if motion means to move, friction means to not move. So the ball's going to the right. So friction is what's going to slow it down. The grass that this ball is rolling on is really going to slow it down. Think of the difference between kicking a soccer ball on like tall grass versus ice. Ice has like very, very little friction, so it makes things very slippery, whereas grass has more friction, so it slows the ball down. So friction slows things down. So you need that hand signal. Okay, so friction, you're going to write this down, slows things down. Here we've got that soccer ball on ice where there's less friction. And then we have the soccer ball on grass, label that more friction. So look how friction is going to the opposite of motion because it's trying to slow the ball down. It's not very successful on the ice because there's so little friction. Okay, so pause this and copy all that down, including the picture. So if friction is the opposite of motion, then friction means to slow things down, like I said. So here, this is like a sticky little thing that when you play basketball, before you go out on the court, you can step on it so your shoes won't be slipping and sliding. I've seen, I don't know if you've ever watched NBA games or college games. I've seen where they lick their hands and put it on the bottom of their shoes. They lick their hands and put it on the bottom of their shoe. And that's to create friction. I know that's pretty gross. This is definitely a more sanitary way, but it helps their shoes kind of stick to the ground. So if you have to make a really fast turn, that you're not slipping and sliding all over the place. Okay, on the right, this is a ballet shoe, a toe shoe. So these are very, very slick on the bottom. And think of what a ballerina does. She's on a stage floor. So she doesn't want to slip and slide around. So what you'll see some girls do that are ballerinas, men as well, is scruff up the bottom of their toe shoes like this. And that gives them some grip on their shoes. If you've ever bought like brand new like boots before, like cowboy boots, they're really slick on the bottom. So anytime I buy a new pair of boots, I always take them outside to the concrete and like scuff them up. So that'll give me more grip and I won't be like falling all over the place. So friction is going to slow things down. So what force is causing this guy to fall? Well, there's very little friction. This is ice. So the very little friction that there is causes gravity to pull him down. So poor guy, very little friction here because he's slipping and sliding on the ice. So more friction or less friction? Okay, this side, more friction because that's going to slow him down. This side, less friction because he wants to slide and glide and go quickly. So more friction because it slows him down more, less friction because it doesn't slow him down very much. What about this one? Have you ever tried to ride a bike in the grass? It's pretty hard. So this has more friction because it really slows the bike down. This has less friction because you can glide a lot smoother on the road. So which type of shoe would create more friction? Definitely the cleats. Cleats that you would wear like for football or soccer is going to create that grip. So it's going to slow you down so you can turn and move really fast. Whereas roller skates are going to have less friction because it's smooth. So rough, more friction. Smooth, less friction. We want less friction in roller skates so we can glide and slide around. So what are they using this spring scale for? This is how we are going to use a spring scale. You hook it onto something and you pull it across flat. So they're testing out the friction of this little green cloth here. So like the green cloth will need more force to pull this block than just like the top of the table will have less force. So the green cloth, it may take like 2 newtons to pull it across because it gets kind of caught on there. Whereas a smooth table, it may only take 1 Newton. It's a lot easier. So they're using this spring scale to measure the friction of the different surfaces. Okay, so you should have your notes totally filled in now. And now you're going to do some activities. So this is your slideshow that you're going to complete. You're going to watch a video clip and answer these questions over here on the right. Now this video starts and stops where you're supposed to. So don't be skipping around on the video. You're only watching a few minutes. If it doesn't stop automatically, it should. Then you don't need to watch past 9 minutes and 45 seconds, but it should stop automatically. So you're actually going to click in here and type in your answers. If you need more room, just make yourself more room in the text box. So you're going to do this slide. You don't need to watch that right now. Same thing. This is just about a 1-minute video clip here. You're going to answer these questions on the right. Nope. And this one. Again, this one should stop automatically, but stop it at 6 minutes, 45 seconds if it doesn't. You only need to watch a few minutes. You're going to answer this question right here. Okay. Last thing, this is your force and motion assignment. Okay, you are going to choose one of the following pictures to write about, just one. You have multiple options. So I have an example for you. You can choose this one. You can't do the example. I've already did it. You can do this one. You can write about this picture, this picture, this picture, or this one. So you're going to be writing over here in this blank space. So choose one picture. You're going to write about what's happening in the picture using all of the vocab that you just learned. Force, motion, friction, and gravity. You can either write it like a story in complete sentences or just make a list of where you found each thing happening. So I've got examples here. So here's a full on, like just put it in this kind of a story form. Okay, but I've got every word, force, motion, friction, gravity. So you can read through that to help you understand. Or you can do it like this. I just listed each vocab word and put where the force is. Where's motion? Where's gravity? Where's friction? So I'm talking about every word. So either one of these formats is okay. Then before you turn this in, because you're going to submit this on Schoology, you can delete the slides that you don't use because you're only going to use, like I said, one of these pictures. So the other ones that you don't use, you can delete. Just do one. Okay. Make sure that you, when you are finished with all of these, that you go back to Schoology and click the turn this in button so I can see all of this. And that's it.